Well, as you saw per the title, it's been a short while since we've last left that scene. The issue there was I went to go grab the capacitors to do this next step, and guess what I forgot to order? Capacitors, that's right. So I had to order the capacitors, wait for them to come in, and that they did. And then the next thing was, well, I'm going to mount this via standoffs, and I was going to use computer standoffs, and I went and grabbed my my container, and unfortunately I was a little weak on that as well. So then I ordered a standoff kit. Now these standoffs here are plastic, and I went with plastic thinking, you know, for conductivity, in case something shorted out, I'd be okay. So what I have done is I went ahead and cut down the perf board and assembled it loosely. Got everything in place. Got my standoff holes cut. And I've loosely got these wires ganged together where they're going to go. So the next step is going to solder this all together and run some short lead wires, which will pick up from these components and go through the hole here to the board. I know you can't see it at your angle, but well, you probably can. I do have the standoff posts mounted, I'm using these ones, to the chassis. However, I ran off and forgot to mount this ground strap tie down, so I'll have to remove this one and put that back down. One of the quandaries I had last go around was what fuse holder was I going to use in this. Once I got everything set aside and laid out and figured out, I decided to go ahead and use this one. Figured this here would be the easiest to access. It's very well protected, and I don't have to worry about anything accidentally hitting or falling on, even though I should have been okay with that. The other thing was, you know, a bunch of hot snot down here along with the fishboard, and then hot snot the connector, and then this. So I think this here would probably be a little more secure and just easier access for the operator to get to and if one needed. The other thing I wanted to do in this was put in a safety capacitor, which you can see right here, this blue box, safety capacitor across the line, and got that in. So I'm real fat and happy about that. So my next step is to go ahead and button this all up, get that tied in properly, get my wire ran for this, and get this mounted. And once that happens, we could flip it over. I need to, I need to clean the tube sockets just for GP. I'll do all this off camera, but we'll flip it over. I get the tubes, we'll test the tubes, the new tubes, see how good they are, put it in, and hopefully we'll actually get to fire this up and, with any luck, watch it blow up. Well, hopefully not, but that could happen. Other things I need to do to it still is I need to clean the electrical contacts, squirt this some cleaner, and see what happens. Let me get that all put together, and I will come back and we'll look at what happened. Okay, so we have the new board all welded up and everything. So we got our positives here for the caps, and then we go in here to a central grounding point. Now this is 18 gauge bus wire, solid bus wire. Should be nice and thick, thicker than that, and so that'll go to my ground point. In case I didn't show it very well last go around, this is what this board looks like. We've got 4 capacitors. These are all 450 volts, and these tall ones are 22s, and these ones here are 10 microfarads. And then the resistors are a 33, a 10, and a 1K. And that'll make up that circuit there. So I think I did a pretty good job, considering it's my first time doing something like this. I mean, I've dorked around, but you know, essentially it's my first time doing something like this, so I think it's cool. Might not be the neatest or the greatest job, but I think it's cool. I could only improve, right? Get this network right here. I'm probably going to have to extend some of the leads and get it all mounted. So I'm looking forward to that. All right, here we are. The next day, I've got the board put in. We're going to take a peek at that real quick. But since I've got it turned around this way, let's go ahead and talk about what I've done here. Don't worry, don't fret about the controls. I just threw them on haphazardly for testing purposes only. I have cleaned these again with contact cleaner, and they're moving just fine, no issues there. Went ahead and cleaned these controls with contact cleaner as well, and then for the shafts I put some penetrating oil, and hopefully that'll free that up and clean that up. I've also taken a pipe cleaner and I've cleaned out the prongs here and banana jacks. So good there. Let's go ahead and spin this around. And here you can see the module board put into place. Well, not the module board, filter board put into place. Let me zoom in a little closer for you. And as you can see, it's mounted in there nice and secure. It looks really good. One thing I did, I went ahead and swapped this resistor back out from the half-watt resistor to, I don't know what this is, but it looks a lot meatier than this. I think this is old school half-watt, or could be 1 watt. I'm really not sure. But I went ahead and put that back in, figuring that that's going to take a lot of heat, where the half-watt probably wouldn't handle it for too long. So we got that in there, and everything heat shrinked in, so we don't have any issues with the hole here. And here you can see the bottom of the board and all the lead dressing that's on. I did replace a couple wires, this green wire and another wire in here. Can't remember the color. Red, I think it was. Replace that so I didn't have a couple centimeters of addition, so I just changed that out and it looks really good. And then I went ahead and took a pipe cleaner and some electrical contact and cleaned all the sockets. I will say this, they are very tight. None of them are loose, so we don't have to worry about replacing any. So feeling pretty good, feeling pretty positive that as long as the work I've done on this is sound and I got everything in place, it shouldn't blow up. However, you never know. After all, I'm blind and I don't know what I'm doing. So what is next to do is I need to pull out the tube tester and the new tubes. We need to test them, see how good they are. And once they check good, we'll put them in here and then we'll actually test this device out. So give me just a moment, set the tube tester up, and we'll run through that real quick. Okay, so I've got the tubes all pulled out of the packings. First time I'm seeing it. And I've also got the tube tester set up, ready to go. Anyway, these here are the tubes that I got. This one here is really cool. This is, as you see, military, and almost like a work of art. Got nice rivets holding it all in. It's really cool. Anyway, that is the VT153, and then here we have the Western Electric, and this is the 12SH7, And then finally we got this one here, CBS 6X 5GT. And I tell you what each one of those do, but I can't tell you that. I don't know. Forgot. Alright, so let's go ahead and let's get set up, and hopefully I won't blow them up this time like I did first time out. I have the 12SH7 in line, and we're going to check it for leakage right now. Turn that on, and then we'll give this a moment to warm up. They say about 30 seconds is what you want. And then let's go ahead and rotate the control, and we're going to pay attention to this light to see if that illuminates. Now it will illuminate when this switch is moved to position number 7. Okay, that's number 7. Perfect. And now we'll see how strong this tube is. That's not bad. 70 something, so we'll work with that. Okay, so next up we have the 6X5 GT. And let me kill one of my lights so we could see the tube glow. And yet we should still be able to see the meter. Let me try this backlight. Okay, that'll work. So let's go ahead and test it for leakage. And hopefully we won't have another faux pas on my behalf. Okay, it's glowing. That's a good thing. Now we need to run through this, and we know that this is a 2-section tube. We do know that number 7 will glow, so let's run through this real quick. So that's one position. There's 7. All right. That is good. Now let's go ahead and check it for leakage, or emissions. Well, that's not very good, is it? Let's give that a second, see if it moves up any. All right, let's go ahead and flick it back over here on leakage, and then we'll put it on the other one. Which is 3. And let's go ahead and bring it over. Well, that one's a little worse. Alrighty, let's move on to the next one. Well, that box was a thing of beauty. Shame I had to tear it up to get into it, but it is what it is. Anyway, this tube here is the VT153, which is a 12C8 equivalence. So that's how we've got the machine set up as. It is a dual tube, so first one we're going to test is off of the cap here, and then we'll move to the second one. And so with this, same story as last, or the rest of them rather. We will see illumination on number 7. So let's go ahead and check for leakage. I went ahead and turned on all the lights since we can't see through that body. No need having mood lights going in a disco ball, I guess. Okay, with some snazzy editing, 30 seconds have gone by. This is warmed up, hopefully enough. Let's go ahead and flick the control. Again, when we get to number 7, that should illuminate. Of course, I know you can't see it because my hand's in the way. Camera's not angled there. However, we are there now. Okay, perfect. Let's go ahead and flick this back over to terminal cap. If you can see my machine, you would see that it says TC for terminal cap. Let's go ahead and check this now for emissions. Well, that's not very good. Maybe it will warm up after a little bit and improve. I can flick this switch here. Maybe my switch needs to be clean. Let me put it in the center. Yeah, see, it's coming up. So maybe my switch is dirty. Let me put this in the center. I know this will give it a little extra juice. Shazamo. Not sure exactly what SPEC stands for, but that's what the center switch is labeled. And that gave it a little kick in the pants. So maybe it'll come back after warm up and I will service my machine one day. Alright, let's go ahead and set it up for the other side. Alright, I have removed the cap and put the plate in its correct position, which is number 4. And we're in leakage. Let's go ahead and turn this on. And same story with the plate. When we hit number 7, the light is okay to illuminate. And let's go ahead and swing this down to 1 and go through the motions. Okay, so that's 7. Okay, so it all looks good. Alright, forgot where I needed to put that. Needed to put it in 4. Alright, let's go ahead and see what it do. Well, I guess I will let this thing sit here and cook a little bit. And if it don't come up, I guess in this case, can't judge a book by the cover. That was a new old stock. And not very well. I'm going to let it cook for a while, see what it does. Okay, the moment we've all been waiting for, well, at least me. Got the tubes populated in. I got the new tubes in there. Just going to run with them. They're not as strong as I hoped, and that one didn't improve much. So we'll just run with it. I do have a fuse in line. I have a 1/2 amp fuse, so hopefully the inrush is going to be slow. We have this on a isolation variable power supply, so that should take care of any inrush. And as you see back here, I do have another camera watching the back, so if anything explodes, I have it on. We'll have it on that camera, and if it does explode, then we will put it in the video If not, if it doesn't explode, nothing ShamWow happens, then there will be no video from that camera. Alright, we have it plugged in, and I'm going to hit the big red switch now. And this is turned off. I'm going to turn this on now. And we have the gain turned low, so we do have power. And now let me go ahead and slowly work up the isolation transformer. Now I'm wearing safety glasses, I don't have my prescriptions on, and reading the meter is a little challenging. So we are roughly about 10 volts. Okay, that's about 20 volts. That's about 40 volts. And take a pause there for just a second. I don't see any tubes illuminating. Well, I could only see one tube illuminate, the rest are blocked. Alright, now we're increasing. We are at 50 volts. And I do not see the filament illuminating. And I can't tell if the magic eye has illuminated yet or not. It has not. Okay, I believe that's about 60 volts. And I don't see that illuminating. Okay, that's 70 volts, 80 volts. Okay, it looks like we got filament glow here. And the magic eye is also illuminated. And we'll spin that around here in a moment as soon as we hit the 120 mark. Okay, that's 90 volts. I would like to think that if something was going to blow up, it would have done it by now. There we have 100 volts. And you can see it in the camera now. That's about 110 volts. And we are currently at 120 volts line voltage. So no big showstopper. That means I did something right. Yay, go team VEG. So let's go ahead and spin this around so you can see the magic tube. That looks wonderful. Very cool. Now let me turn the speaker on real quick. And we'll turn the gain up. I don't hear anything. Let me stick a probe. Yeah, I'm not hearing anything. Let me get a sound source one moment. I have a audio generator plugged in. I'm at about 537 hertz, just where the dial landed. I have my other vintage Radio Shack signal tracer, and so to see if I soldered this capacitor in properly, just come to this side and touch, and as you hear, that is working. So I go back to another thought of, well, you know, I don't really have any experience with these foil capacitors, and as I stated in the beginning, I did not know what the magic secret was in testing these capacitors to find out what the foil side was, so I just stabbed them in, called it a day, knowing that that could be problematic. So I grabbed another capacitor, not sure if it's the same value, but the value I grabbed was .022 microfarads at 630 volts. So I grabbed, touch it, and as you see, the capacitor does pass a signal, so I flip it around, test it, passes a signal. So I come to this side of that cap and I have no signal. Bypass the cap altogether and no signal. So now the troubleshooting is on. I'll probably remove this side of the cap from the board and see what happens. I think maybe my issue might be right here in this connection. Now I'm going to fire this back up and test it. Off camera, what I did was I cleaned the terminal of this tube with one of these things and cleaned that up, and then tried my best to clean the inside of this top cap with, well, one of those things. I don't know how successful I was, but now with this turned off and unplugged, got the input going in, and my signal tracer is right here. And if we see, we can go, let me turn that up just in case we can't hear it on the microphone. You can see now with that cap floating, we do have signal passing. So that's again telling me that I have a good connection here and this capacitor is working. So if I take my thing here and I tap here to see if I now have a valid connection from here to here, you can see it does. So right now I'm not able to get that to break signal. I'm just going to leave that finger tight right there, and just go ahead and plug this all into the isolation transformer. And since we're at 120 volts on the Richter scale, we're going to leave it there. Okay, so the power is off. Let me go ahead and turn the transformer on. Okay, we have full power going to it. And let me reach over here, get my big fat arm out of your way, and turn this on. Turn the gain up a little bit. I also found by running through the switches that I have to have this switch into high gain in order for it to properly pass a signal. Let me turn this on. So we see we still have a signal going through that signal tracer. However, going through this signal tracer, I'm not hearing a thing. And you see that? If I flick this switch from high gain off, then that works. I think I got the speaker on this one turned off. Let me turn that on. All right. Nothing. So I reckon flip this over and probe pin 4 and 5 and see what happens. However, before I do that, this is the new tube, and I was thinking that it would be okay enough for testing, that it would allow signal to happen, but let me turn this off and get my arm out of your way. Let me swap that tube out real quick with the old tube, and we'll retest this. I don't know why I added a T in this. Be right back. Okay, so I have the old Sylvania in, and I did test this off camera because it's been a while since I looked at it. And one side is weak and one side is really, really good. But I would almost think that even weak, it should produce some kind of noise. But as we saw, the new one, the new old stock, was 20% both sides. So let me go ahead and, let's see, do I got this? Yep, that's off. Let me turn on the isolation transformer. Okay. And now let me turn this on. And we can confirm with the Radio Shack that we do have signal still passing through up to that point. We are illuminated, and I got the gain all the way up and nothing. Oh, there we go. So I wiggled the switch. I bumped the switch, so I might have a bad switch still. Yeah. Okay. Well, that is good. Let's spin this around without getting bit and see if we can see the eyeball. Okay. I may have my eyeball in wrong. So I just stabbed it in there. Not very loud. Let me bump you out. Alright, so you see if I'm wiggle that. So I apparently still have a faulty switch. Because that's the gain wide open. And you know that that Mr. Carlson's mod that I did, it very well could be that Smiley capacitor could be the wrong one. Might be choking it too much, so I'll probably swap that out. Let me turn that back up. And what I want to do is, let me turn one of my lights off and we could look at the meter better. I'm going to change my gain, my amplitude on the audio function generator. And the magic eyeball is not working. Interesting. Let me take it off of RF and put it over here on AF. Just barely anything. Well, now that's working. But I have to have the gain here all the way up to hear something. So let me tack that capacitor back in here. Let me swap out that disc capacitor for the right one. And let's see if that makes a difference.